There are hundreds of billions of alien worlds in the Milky Way galaxy, and scientists have already discovered and confirmed over 5,000 of them. They call these worlds exoplanets. Some of them, like Kepler-37b, are really small and even smaller than Mercury, the smallest planet in our solar system. Kepler-37b is slightly larger than our own moon and is located 208 light-years from Earth, orbiting a star that is smaller and cooler than our Sun. Scientists have confirmed about 200 small rocky worlds like Kepler-37b, which are rare finds due to their tiny size. Most of these planets are much closer to their stars than Earth is to the Sun. For example, Kepler-62b, a Mars-sized exoplanet, orbits its star approximately 4 times closer than Mercury orbits our Sun and completes a full orbit in a little over 12 Earth days. Another extreme case is Koi-55b, which used to be the size of Jupiter but is now evaporating due to its proximity to its star. These exoplanets often have their atmospheres torn away by their host stars. G1132b, a super-Earth located 41 light-years from Earth, might have had a thick hydrogen atmosphere in the past, but it was stripped away, leaving only a rocky core behind. Despite some challenging conditions, scientists have found slightly larger super-Earths orbiting in their Sun-like stars' habitable zones, increasing the possibility of life. To learn more about these planets' atmospheres, further exploration up close is necessary. Intriguing, Kepler-452b is 1.6 times the size of Earth, and it's about 6 billion years old. Earth, on the other hand, is a youngster compared to this world. Our planet is only 4.5 billion years old. Okay, now I know this is your favorite exoplanet, Kepler-22b. I like it too. This super-Earth might be covered in a super-ocean. It sits comfortably in its star's habitable zone and has a huge potential for life. The only problem is that it's big. Kepler-22b is 2.4 times larger than Earth and about 9 times more massive. If Kepler-22b was the size of Earth, it would have an average surface temperature of about 16 degrees Celsius. But because it's a lot bigger than Earth, it could be a rocky planet, a water world, or even a gaseous planet like Neptune. Speaking of gas giants at this size, exoplanets stop being super-Earths and become gas giants. More than half of all exoplanets we've discovered are either Neptune-like ice giants or gas giants like Jupiter. Many of them orbit a little too close to their host stars, and they pay a high price for that proximity. For one, they're incredibly hot, and sometimes their host star rips their atmosphere away, kind of like what G1132b went through. But among them, there are also some cold planets too. One example is Kepler-16b. It's not quite as large as Jupiter, but the cool thing about it is that, note, the text provided by the user seems to be unfinished. The sentence does not have a clear ending. Please provide more information or specify the exact question you would like me to address. It orbits not one, but 2 stars. Only you wouldn't be able to see those stars because you wouldn't be able to stand on its surface. You see, Kepler-16b is a Saturn-sized gas giant. It might have some rocky elements inside it, but its 2 host stars are much cooler than our Sun, making Kepler-16b a frigid, lifeless world. Speaking of lifeless worlds, that might be what Earth becomes if we don't work to stop climate change. You've seen the hundreds of wildfires spreading across Canada. Well, this is due to climate change making the world hotter and drier. This toxic air made its way to New York, Toronto, Detroit, and Chicago, resulting in some of the worst air quality in the world. California is trying to prevent wildfires by purposefully burning thousands of acres a year. This is in order to reduce vegetation that could fuel a catastrophic wildfire. And this is just one example of what we need to do to help with climate change. Check to see what your local and federal governments are doing to help, because we only have one Earth, and we don't want it to turn into one of these uninhabitable exoplanets. Okay, now onto the worlds that are bigger than Jupiter. This delicious exoplanet has the density of a marshmallow. TOI 3757b is slightly larger than Jupiter, but it's not nearly as massive. But there are always bigger and badder planets out there, like Kepler 7 bits. This one is interesting. Kepler 7 bits is larger than Jupiter, but it has half of Jupiter's mass. This means the planet is like a super-light cloud, a scorching hot super-light cloud. Kepler 7 bits is a hot Jupiter planet. It's 12 times hotter than the king of the solar system. Still, Kepler 7 bits is not the hottest or the weirdest of the exoplanets. Some of these gas giants are so unimaginably hot that they tear molecules apart. Yeah, and some planets are just doomed. 1,400 light-years away from Earth, a star slightly bigger and hotter than our Sun is devouring its planet. This planet is called WASP 12 bits. It's almost double the size of Jupiter, but it's not going to last very long. As far as planetary lives go, WASP 12 bits is so close to its star that it takes just over 1 Earth day to complete its orbit. Its own star is actually eating the planet's atmosphere, making it stretch into the shape of this egg. 10 million years from now, WASP 12 bits will be gone. And some exoplanets are unimaginably huge. The biggest one of them is almost 7 times larger than Jupiter. HD 100,546 isn't just 7 times larger than Jupiter, it's also 750 times more massive. HD 100,546 orbits its star 10 times further away than Jupiter orbits the Sun. That's pretty far. And it makes scientists wonder how this gigantic exoplanet formed so far away from its star. There's no doubt that some exoplanets out there look promising for finding life. We found quite a lot of them orbiting in the habitable zone of their stars. In fact, some of these worlds might even be better for life than Earth. But in conclusion, the universe is full of fascinating exoplanets that come in all shapes and sizes. From planets like Kepler 452 bits and Kepler 22 bits, which have the potential for life, to gas giants like Kepler 16 bits and WASP 12 bits. Each exoplanet has its own unique characteristics and challenges. Climate change is a pressing issue that we must address to ensure the continued habitability of our own planet. Taking action at both local and federal levels is crucial to protect our environment and prevent the catastrophic consequences of climate change. As we explore further into space, we discover more and more massive exoplanets like TOI 3000, 757 bits, and HD 100,546 b. Their existence raises questions about how such giant planets can form so far away from their stars. While some exoplanets show promise for finding life, there is still much to learn and discover. Studying these distant worlds gives us insight into the vastness and diversity of the universe. In summary, the study of exoplanets allows us to expand our knowledge of the cosmos and raises important questions about the potential for life beyond Earth. It emphasizes the importance of protecting our own planet and advancing our understanding of the universe.